This is part 9 in a series of videos in which I'm developing a 40-channel logic comparator, or it's part 7 in a series of videos in which I'm repairing an HH Tiger, depends on how you look at it. But what I want to do in this video is just show how useful the logic comparator can be. If you have watched the series of videos on the repair of the HH Tiger, then what I would say at this point is this is starting to look very like the repair on an HP calculator I did about a month ago. There's so many failed parts on this board that I suspect there was an issue with the power supply at some point. Almost every major device has failed on this. Now luckily they are all fairly easy to get hold of, so I've been working my way through and finding out just what the extent of the failures are, and luckily with this machine pretty much every IC on it is in a socket, so that actually made this an ideal candidate to test the logic comparator, so I could do easy swap outs rather than having to mess about if I suspected I had an issue with the comparator. So far it's been behaving quite nicely. Now one of the things that I want to do is make sure that if you do decide you want to buy one of these, then I can give you some advice on what type of test clip to use. All the components are fairly easy to get hold of, but the one that makes the biggest difference on a test device like this is the clip-on test clip that you use. And so to try and help, I've been testing a whole range of different clips from these very cheap, or at least they were very cheap, RS type, which are now quite expensive and only really available second hand, to cheap Chinese knockoffs. I really do not recommend these. They are extremely difficult to use, they give very poor connection and they're inconsistent. All the pins are in slightly different positions, they're not all in a straight line, so when you clip it on, one or two of the pins might not be making contact and you can waste a lot of time trying to make these things work. And then of course you have 3Ms. These are good, horrendously expensive, but they're fairly hard to get hold of, especially in the UK. You can get them, but as I say, they're quite expensive. One that I've been kind of zeroing in on is this type. I haven't fully decided this is the one I want to use yet, but so far it's way ahead of the others. That's what I have connected to the logic comparator at the moment. So the way I'm making these test clips up is I'm getting old IDE cables and cutting one end off, stripping the ends, and then I crimp connections onto the end. So rather than soldering the leads direct to the test clip, I make up semi-generic connectors at the end. So this is a 14 or 16 pins, so as you can see it's a 14 pin clip, but I've just got it plugged in to the top 14 pins and I'm leaving the bottom 2 unused, but of course I could take this off and put it onto a 16 pin clip. The other thing is to use, and what I will be recommending is use what are called knife edge clips as opposed to the duckbill. You probably can't see this on the camera, but on the 3M one I have here, the end of the test pins is flattened out. It's a bit like a duck's bill side on, and they give you a wide contact area. Now that's fine for new ICs, but because the device I suspect will mostly be used to test and repair old equipment, as I'm sure you know, if you do this sort of thing you get a lot of corrosion on the pins of these things, and the knife edge connections, knife edge pins are exactly what they say. If you look end on, they're kind of like a knife edge where the point of the knife is trying to make contact with the pin on the IC, and of course that means it's much easier for it to kind of bite through the corrosion. It's not going to cut the pin off or anything like that, it's not that sharp and there's not that much pressure on it, but there is enough to break through the corrosion and give you reliable contacts. Also these have a very nice spring pressure. One of the issues with the 3Ms is they are incredibly stiff. So this, as I say, so far is ahead in the race. If this does turn out to be the one that I recommend, then if you buy a set of boards, I'll also supply an order sheet, or at least a part sheet for this type of connector. And as I say, this will make a big difference. Having reliable connectors makes a huge difference. So with that said, what I've been doing is working my way through the board. You can do it with a scope, but with a lot of the devices, especially the active ones, it can be difficult to determine if they're working or not. But I'll just show how this is used on an actual working board. So you put in the type of device that you want to test, and because there are so many failed parts on this board, what I've been doing is shotgunning the testing. So I'll put a part in here, and then I'll test all the similar parts on the board and see if any are showing as faulty. And it's a very quick way of completely eliminating all the faulty parts, and then you can look at track failures, that sort of thing. As I said, the test boards in here, you can configure them such that they will cater for quite a few different ICs without having to change the jumper settings. So this will do all the 2-input quad gate types, or at least all the standard ones. And that means that all I have to do is pop the chip out, put the next chip in, and then test all similar devices, and then just keep doing that until I need the next type of adapter board. So once you have your device in the tester, all you do is clip the test clip onto the device you want to test. And so once that's clipped on, you simply power up. And as you can see here, we have a fault indicated for this particular IC. This is why I'm making the video at this point, is I had already tested this device, and so I know it had a fault. It's a very clear fault. Gate A, the output is stuck, it's not changing. If you put a scope on the input, then you'll see the inputs are changing but the output isn't. And so what I'll do is I'll swap out the chip and we'll retest and see if we've eliminated the problem. Okay, so I have a new device fitted to the board. I've reattached the tester, so we'll power up again. And as you can see, we now don't have any warning or failure lights showing up. So all you do now is you just take the clip off this one, put it onto the next of the same IC type. This is a 7400, and then you'll change it to the next IC type and do the same thing again. It's not the way you'd normally go about testing a board like this, but as I say, this has so many failures that that's the way I've decided to test it. All the ICs on, or at least all the memory ICs on this board, for example, had failed. So as you can see, I've swapped those out and put sockets in. I'm not sure about the other two cards yet, I'll come back to those another time. But what I want to do now is just get all the bulk of the failures out of the way, and then see if the machine's any closer to running. But again, hopefully you can see this is quite a useful device, and it makes it very quick and easy to detect if there are any faults on any ICs. And I have been testing the bigger ICs as well, and it works in exactly the same way. You just clip the test clip onto the IC, put the card in with the correct IC into the tester, reset the Tiger, and then you'll look for any error indications. And it has been working quite well so far. I've tested everything from the display device. I've also tested the 82720 in its place to see if that is a pin-for-pin compatible, or true pin-for-pin compatible with the original display controller. This is one thing I'll be coming up to in a future video, is the sourcing of alternate parts when you're trying to do repairs like this. Very frequently, back in the late 70s, early 80s, and even into the 90s, ICs like this were licensed out to other manufacturers, and so you'll find there are what amount to clones, albeit with different specifications and part numbers. The specifications normally fall within the range of the original part. It might be slightly different, but it functionally in most instances will work. But things like Z80 processors, it's available in what will amount to industrial part numbering systems, where it's got a completely different part number, but it is a true Z80, and quite often they are very high performance versions. But as I say, I'll come back to that in a future video. But for now, as I say, I've just been testing all manner of things, including the PIO and the CPU itself and the DMA controller, and it is working extremely well, and it has allowed me to detect and eliminate quite a few faults that would otherwise have been quite difficult to fix. If you're interested, the current fault I'm chasing on the Tiger is there's no CAS signal. There's a RAS signal but no CAS, so the Z8 is only going so far through the boot process up to the point where the memory contents are corrupt, and then it just crashes. So that's what I'm chasing at the moment. Unfortunately, I don't have a schematic. If anyone's got one, I'd very much appreciate a copy of it. The CAS signal is quite a convoluted control system that I'm trying to track back to see where that signal is going wrong. Okay, so any questions, then please let me know. But as I said, the point here really is just to show you how the logic comparator is used for actual system testing.